Ah, wait, now it's working. There's something about when I bend over so that I'm out of view and then I stand up, it works. But when I stand up here in advance, and it doesn't seem to work. But now it's working. I think we're on. Okay, so yesterday we talked about solving one-step equations, right?
Wasn't that two-step?
A one-step equation. We had two possibilities. Actually, we had three possibilities. Let's just look at our three possibilities. We had x plus 4 equals 12. And then we had 5x equals 20. And then we had 1/4 x equals 10, something like that. Those are our three one-step equations. The reason they're called one-step is it just takes one step to solve them. What's the one step I'd have to do here? Sal. Minus 4. Minus 4 from both sides. And suddenly I have x is equal to 8. What's the one step I'd have to do here?
Divide.
Okay, divide by
5.
Divide by 5, so that's one step. X is equal to 4. What's the one step I'd have to do here?
Multiply both sides by the reciprocal of that fraction.
Right, so multiply
as dividing.
times the reciprocal, 4 over 1. And 4 over 1 is the same as 4, right? Isn't 4 over 1? So I don't have to do it 4 over 1, I can just say 4 here. So those cross out, so all I have left is x is equal to 40.
Technically, that's dividing. Right, multiply.
Right, yeah, exactly. When you multiply times its reciprocal, technically you're dividing. That's why I talked about that yesterday in the lecture. But all complicated equations, solving complicated equations, all it is it's just a combination of these, with the exception of maybe your distributive property. And then I might make it a little harder with fractions or with decimals, right?
Nice.
But it's still the same process, right? Totally the same process. So let's look at this for a second. Actually, let's look over. I just want to be sure you can see this on the screen. Yes. All right. So everybody knows how to do this, right? Fist of 5. Everybody knows how to do this, right? Like piece of cake, right? Everybody. Yes. Now watch this. What if I did this? I made one change. I'm just going to make one change. I am going to put a 2 in front of the x. So if I had that now as my problem, 2x plus 4 equals 12, I would solve it the same way I was solving it, as though it just said x plus 4 equals 12. I would remove the 4 from both sides. And the only thing is, I would now have a 2x down here equals 8, right? And what would I do now?
Divide both sides.
That style, right? So I divide by 2, and then I have x is equal to 4. You guys now know how to do a two-step problem, to solve a two-step equation. They're really quite simple. So let's try a few. Let's say we have 3x plus 10 is equal to 40. What would I do? Oh, yeah, what do I do? First thing, yes, Hunter.
We have to get rid of that 10. So
Yeah, you got to get rid of 10. Don't ever, this is what sometimes some people try to do this. They say, some people try to do this, do not do this. Don't go 3 and 3. First of all, you didn't do it right. Second of all, you're going to get the wrong answer. And third of all, it's a nightmare. You're making it harder for yourself. First of all, if you were going to do both sides to divide by 3, it would mean you'd have to divide everything by 3. Suddenly you have 10 thirds and 40 thirds equals 40 thirds. They're going to have weird numbers, right? Mixed numbers. That's hard. That's the hard way. Don't do it that way. Always do it just like a two-step, like a one-step. Get rid of that 10 first. Subtract the 10. Subtract the 10. Draw your line. This now is 3x is equal to 30. Now what?
Divide.
Divide by
3.
3. Those cross out. Divide by 3. X is equal to 10. Good job. Piece of cake, right?
Yeah.
Like really a piece of cake. It's so simple. All right. Well, I'm not even sure. Okay, well, I'll do another example. we'll just do a few examples just so that you guys really get it. And then I'm going to show you multi-step, solving with multi-step equation, right? All right, so how about negative 4x minus, I don't know, 5 equals, what do you think? Equals 19. We'll just do that. We'll make it negative 19. Make it fun, all right? So what would I do? Yeah, this is what I got to work with. I got to add 5. Notice whenever I do this, whatever sign is here, you're going to do the exact opposite sign here. Have you all noticed that when you're working on it? If it says minus 5, it's going to be plus 5. Always going to be the opposite. It's going to be plus 5 over here because it has to be the same thing on both sides. Negative 4x, these cross out, equals, what's that?
14.
Negative 14, right. The 19 is the bigger number, right? I mean, absolute value of negative 19 is 19. So you're going to keep the sign of the larger absolute value number and then subtract 5 from 19, you get 14. All right, now I'm going to divide by negative 4. Divide by negative 4. All right, so the negatives cross out, the 4's cross out. I have x is equal to the negatives, top and bottom, they cross out. So all I have left is 14 over 4. Let's see, 2 goes into both of those, right? 2 goes into 14 7 times. 2 goes into 4 twice. So my answer is 7 halves. Or I could turn it into a mixed number,
Just 3.5.
which would be 3.5
Yeah.
or 3.5,
Or
right? Or, right?
3 and 2/4. Oh. 3 and 3/6. Oh.
Right. So pretty awesome, right? Okay, now we're gonna
Sure is pretty.
now we're gonna just adjust the title of this thing. Solving.
3 steps.
I'm gonna just call it multi-step equations. This is like what I gave you with the balance scale. All right. So we have 5x plus 2 equals 3x plus, I don't know, 10.
5 what?
5x plus 2 equals 3x plus 10. Remember the scale?
Yep.
Remember I had 5 of these little green things on the scale? And then I had 3 on the other side, 3 of those little green things, and I didn't want the green things on both sides? You cannot solve this if you don't get rid of, you've got to get all the x's on one side. That's why on the scale, I took 3 off this side and 3 off this side. Remember that? You remember that?
That perfectly balanced.
So I find on both sides I have x's, and I take the one that has the smaller number of x's, right? The 3x, right? There's 3 x's. That's x plus x plus x. This is 5 x's. X plus x plus x plus x plus x, right? I am going to subtract the 3x from this side and subtract the 3x from this side. I notice I put it right underneath the 3x here and right underneath this. Again, subtract because this has a hidden plus sign, right? And I draw my line, and what do I have? If I have 5 x's and somebody comes and takes away 3 x's, how many x's do I have?
3 X's. Wait, no, 2 X's.
Right, I have
They said
2
2 X's.
x's, right? And then plus 2 equals, this crosses out, 10. What is this now? This is called a
2 steps.
two-step equation, right? So awesome. So two-step equations, what do I do? Somebody else, somebody new who hasn't said anything. Quick, fast, Wyatt. Fast. Think on your feet, fast.
Yeah.
Minus 2, right, okay, good. I was trying to get them. Okay, so 2x, those cross out, equals 8. Okay, Adam, fast. What do I do? Sorry. What do I do? Where are you? There you go. All right, what do I do? Quick.
Solving 2.
All right, so divide by 2. x is equal to 4. You got it. So you guys can do them. These are complicated problems, and you guys can do them. All right.
Give us a really,
So in your notes, I'm going to put one up here. I want you to do it. In your notes, okay? Question.
Okay, so for how come you subtracted 3? Why not 5?
On this one?
Yeah.
All right, remind me what it was again. It was 5x.
Plus 2 equals 3x plus 10.
Okay, how come I did what?
How come you subtracted 3? Why not like another?
See, I subtracted 3x.
Yeah, but like how? Oh.
See what I mean? I don't want to have x's on opposite sides. I want only my x's on one side of the equal sign. And so I'm choosing my smaller number of x's. There's 3 x's here and there's 5 here. And I'm going to subtract my smaller number. And then I'm going to subtract 3x from here. Now if I had done this, if I had said minus 3 without the x, that's impossible. I mean, I can't take 3 away from 3x. You're right? Because that's not a like term. It has to have that x there. And then I have my 2x plus 2 is equal to, those cross out, is equal to 10. Does that make sense?
Yeah.
Is that it? Was that your question? Okay, cool. So good. All right, so here I'm going to give you a problem. Try it. Try one problem in your notebook. I'm going to give you 20 seconds.
What?
And then I'm going to start solving it on the board. Because this is on videotape, right? So we got to do something like that. Okay, here we go. 7x plus 5 is equal to 5x minus,
11.
let me think.
24.
I'll do 11. That's fine. Minus 11. There you go. Go for it. I don't even mean to hurry you, but that's already 5 seconds. Just kidding.
What is it?
So this just becomes.
How many people got it?
I
Good job. How many people are still doing it but are doing it
Oh my
right?
god, I'm almost done.
Awesome. That's awesome. Good job. Good job. So one of the places where somebody might have messed up is they might have said they might have, let me see, what they might have.
They might have said like plus 5 and plus 5. Oh,
Yeah, they might have said, a lot of times this is what happens. People have put plus 5, and then it's wrong.
You're supposed to subtract 5 from all those places.
You have to subtract 5 from once from each side of the equal sign. Right? I can't take 5 away from 2x because they're not like terms. But I could take 5 away from 5.
Like you take 5 away from 7, and then you take 5 away from 5, and then you take 5x away from 5x.
Yeah, but I didn't take 5 from 7. I took 5x from 7x.
Yeah, okay.
Those are different. Because those are different things. Because that's the 5x, that's the 5. They're not like terms. They're different. They look the same because they both have 5s, but they're different. You see what I mean?
Not really.
Okay, so the first thing you do is you move the x's over to the other side.
Use the other ones too?
Because I want to have all my x's on either left side or the right side, just one of the two sides, right? So I notice there's a 7x's here, there's 5x's here, 5 is smaller. It doesn't really matter which one I move, but if I move the 7x, if I subtract 7x's from both sides, I'm going to have a negative 2x here. And that's okay. Yeah, that's all I did. I subtracted 5x from this side and from this side, and that gave me 2x's left over,
Okay, I get it.
right? And then this is still the same, and this is still the same. And then I've got my two-step equation. I'm going to just subtract 5. Subtract 5. The confusion is I have two 5s in here, right? But I shouldn't have done that to you.
Okay.
All right, let's try one more. One more.
Give us only 15 seconds this time.
All right, here we go.
No.
All right, 8x plus 3 is equal to, we'll do 4x. What are we going to have here? That's plus 15. Okay.
Minus.
Oh.
You guys got it?
No.
Excel. That's good.
People are still with me? Is this what, am I doing what everybody's done so far?
Yep.
Am I doing it right?
No.
All right. And then the last thing I need to do is this, right?
Yeah.
No. That's a bad Gary.
Oops.
It feels all. Yeah.
All right.
Now talk.
So x is equal to 3. Did it make sense, Liam?
Where did you get
Confusing? Where did I get the what? This 3?
No, it's by 4.
So I have 8x plus 3 equals 4x plus 15, right? And I'm going to look at my x's. I've got 4x's on the right side of the equal sign and 8x's on the left side. So I'm going to subtract my 4x's on the right side. I'm going to subtract it so that I no longer am going to have x's on the right side. And then I subtract 4x's over here, so all I have left is 8x's minus 4x's is 4x.
No, but where did you get the minus 3?
Because now, look, here's my two-step equation. 4x plus 3 equals 15. And I want my x's all by themselves. So I got to get rid of this 3.
Okay.
So I'm going to subtract 3. That was a plus 3, I got to do a minus 3. I got to do the opposite of what's there. And then a minus 3 here. Does that make sense? And then I no longer have that number. All I have is 4x equals 12. Divided by 4, divided by 4. 12 divided by 4 is 3, right? Make sense? Okay, that's it for the lecture. Good job, guys.